Early in the morning, 48 kilometers south of the mountain, an Airbus A319 aircraft was flying at an altitude of 9,800 m when a serious incident suddenly occurred. A loud explosion echoed in the cockpit, turning this flight into the focus of global attention. The windshield in the cockpit suddenly shattered and detached. The co-pilot was sucked out of the cockpit. Several control systems failed, causing the aircraft to dive uncontrollably. In a severe oxygen-deficient state, with freezing temperatures outside and violent turbulence at high speed, the three pilots were forced to face unprecedented challenges. The question was, could they manage to bring the aircraft back safely? From the skies over the Qinghai, Tibetan Plateau, where the average altitude exceeds 4,000 m above sea level, on May 14, 2018, Zhongbei Airport in Chongqing entered a busy week. From early morning, passengers arrived to prepare for flights to destinations all over the country. Among them was Flight 8633 operated by Sichuan Airlines, using an Airbus A319. It was scheduled to carry 119 passengers from Chongqing to Lhasa. The captain in charge of the flight was Liu Chuanjian, 45 years old, and a graduate of the Second Aviation Academy. After graduation in 2006, he joined Sichuan Airlines as a flight instructor with extensive experience. He was known for his professionalism, composure, and confidence on the job. Colleagues praised his solid flight skills and perfect safety record. He had never caused any incidents due to human error. Alongside Captain Liu were second captain Liang Peng and senior co-pilot Su Yuetian. Both had obtained high-altitude flight certification since 2016. Assigning 3 pilots, including 2 captains, was part of safety regulations for operating flights at China's high-altitude airports. This cockpit configuration enhances coordination and response capability in emergency situations, enhancing flight safety. According to the investigation report, Captain Liu had a habit of regular physical training. However, he also suffered from white coat hypertension, a condition where blood pressure spikes under stressful environments. Though this condition requires no treatment and does not affect his ability to fly, it became a contributing factor in this event. At 6:27 a.m. Beijing time, Captain Liu took off from runway 2L at Chongqing Zhongbei Airport. 29 minutes later, Flight 8633 reached an altitude of 9,800 m when the terrifying incident suddenly occurred. While flying over Chengdu, everything on the flight seemed completely normal. Only some light turbulence was felt after passing through a key flight segment and entering stable cruising mode. Second Captain Liang Peng, the third member of the flight crew, left the cockpit to take seat 1F in the passenger cabin. At that moment, flight attendants began cabin service. As it was an early flight, most passengers were resting in their seats. Few were moving around, and everyone had fastened their seat belts as instructed. At 7:07 a.m., Flight 8633 passed over Jiabu, navigating waypoint Micus on Airway B213, officially entering the airspace over the Qinghai, Tibetan Plateau. From the right side cabin windows, the Siguniang Mountains appeared brilliantly, as dazzling as ever. But just 20 seconds later, a loud bang erupted. The cockpit windshield, on the right side, developed a web-like pattern of cracks, spreading rapidly. The ECAM system in the cockpit immediately displayed a failure warning for the right windshield heater. This indicated that the heating function had stopped working. The flight crew responded extremely quickly. The co-pilot immediately opened the electronic flight computer to look up emergency procedures for windshield failure in the quick reference handbook, QRH. Meanwhile, the captain gently reached out and touched the cracked windshield. The moment he touched it, he immediately felt the sharp cracks, indicating that the inner pane had broken. Just 5 seconds after the inner layer cracked, a second loud explosion erupted in the cockpit. The middle windshield layer also shattered. Clearly, this aircraft could no longer continue on to Lhasa. The captain immediately made a firm decision. "I'll take control." Then he sent a radio message to Chengdu Area Air Traffic Control to request emergency return. Chengdu, this is Sichuan 8633. We have a malfunction. Request to descend. Sichuan 8633, descend to 8,400 m and maintain that altitude. Descending to 8,400. We will return. The windshield is cracked. Windshield is cracked. Yes, that's right. Sichuan 8633. Confirm returning to Chongqing. No, diverting to Chengdu for emergency landing. Copy that. Just then, another loud explosion occurred. The right cockpit windshield shattered completely and blew off the aircraft. To understand how serious this was, you need to know that the Airbus A319 windshield is extremely tough. From outside to inside, it consists of an outer meteorological coating, a polyurethane layer, a middle polyethylene layer, an inner glass layer, and finally a silicon layer that bonds them all together. The total thickness of the three glass layers reaches 19 millimeters, strong enough to withstand bird strikes, hail, or lightning. However, Flight 8633 was flying at nearly 10,000 m altitude, in completely clear weather conditions. There were no birds, no lightning, no rain or snow. So why did such a strong windshield suddenly shatter? In fact, to prevent windshield fogging or icing, which would obstruct pilot visibility, Airbus engineers designed a heating layer on the inner surface of the outer pane, and that was the key factor leading to the incident. The aircraft windshield is equipped with a transparent heating film, flexible and conductive, operating much like an electric blanket. When electric current flows through resistance wires, it generates heat to warm the glass. There are a total of 6 wires connected to the heating film. 2 AB wires provide power, while the other 4 serve as temperature sensors. These wires are embedded within the insulating silicone adhesive previously mentioned. In theory, this adhesive is meant to protect the wiring system from environmental impacts outside the aircraft. However, during manufacturing of this aircraft, the aluminum tape inside the silicone layer was not fully pressed flat against, creating a gap between the adhesive and the glass surface. When the plane operated in natural conditions, it was easily exposed to moisture and humidity. These water droplets could penetrate the outer meteorological layer and accumulate in that gap. This caused the wires to become damp. Over time, the insulation around the wires degraded. When the windshield heating system was activated, those damaged wires were prone to electric arcing, which generated extreme heat. This abnormal heat source damaged the structure of the dual-layer windshield. Because the inner glass is not the load-bearing layer of the structure, it could not withstand the pressure difference between the cabin and the outside air. At 9,800 meters altitude, just 35 seconds later, the outer glass also shattered completely. The right side windshield was torn off from its safety frame. The aircraft immediately experienced sudden decompression. At high altitude, the extreme pressure difference sucked the co-pilot out of the cockpit. Fortunately, he was still partially secured, thanks to the waist safety harness, so only half of his body was ejected. The violent suction also pulled along the sunshade, the control panel, the flight control devices, and the co-pilot's electronic display screen were severely deformed. The cockpit door automatically burst open due to decompression and slammed violently into the switch panel behind the co-pilot's seat, causing 17 switches to pop out on their own. As a result, the DC electrical systems 1 and 2 were disconnected. The automatic braking system stopped working. 3 computers controlling the flaps and rudder, including units 1, 2, and 5, simultaneously malfunctioned. The co-pilot's headset, his personal flight computer, curtains and pillows in the were all sucked out of the aircraft. This shows how terrifying the power of sudden decompression at high altitude can be. In that moment of crisis, the captain's first instinct was to pull the co-pilot back in, but he was immediately pinned to his seat by the strong wind, unable to move. Realizing he couldn't reach the co-pilot, he shifted his attention to the flight controls and noticed the aircraft's attitude was becoming unstable. The co-pilot being pulled out had accidentally hit the right control stick, causing the autopilot system to be unintentionally deactivated. It was not done manually. At the same time, due to the DC power failure from the switches popping out after the windshield incident, voltage dropped, causing the flight control computers to partially lose functionality. Just 5 seconds after the windshield broke, the lateral control system began to show errors. The aircraft started banking to the left. At this time, flight control computer number 2, which had just taken over from unit number 1, also lost power after 30 seconds and shut down. The aircraft continued to roll even more sharply, reaching an angle of up to 51. The automatic engine control system also shut down due to the power failure. At this point, the aircraft's engines were still producing thrust in cruise mode. If the pilot did not intervene promptly, the plane's tilt would continue to increase, with a very high risk of losing control. Noticing the aircraft's unusual attitude, Captain Liu immediately reduced GA thrust, cutting the engine power, to stop the aircraft from accelerating further. Without support from flight control systems and lacking aerodynamic surfaces, he made an effort to manually stabilize the aircraft. At that decisive moment, Flight 8633 narrowly escaped plunging into chaos as the aircraft returned to a stable attitude. Had the issue not been handled within just 3 minutes, the plane could have crashed straight into mountains, with average heights of up to 5,000 meters on the plateau below. After stabilizing the aircraft, Captain Liu continued to face numerous issues arising from the broken windshield incident. At that point, he was unable to determine if the aircraft structure had suffered severe damage or not. Meanwhile, the sudden decompression at high altitude forced the crew to quickly descend to ensure passenger safety. But there was an especially complicated factor. The co-pilot was still stuck halfway outside the aircraft, battling extreme cold and violent winds. The captain faced a difficult dilemma. If descending too quickly, he feared the co-pilot might not survive. But if descending too slowly, passengers could suffer from oxygen deprivation. Ultimately, he chose a compromise solution, descending at a moderate rate to balance both factors. At Chengdu Regional Air Traffic Control Center, Controller La Tianvu noticed that Flight 8633 was losing altitude, while simultaneously starting to turn left. Concerned, he immediately transmitted, "Sichuan 8633, turn right continuously towards Songchao." Sichuan 8633, Chengdu calling. However, there was no response at all. The controllers were forced to ask for assistance from other aircraft on the same frequency. Tibetan 9832, respond to Chengdu. Can you call Sichuan 8633 on the same frequency to see if they can hear? Sichuan 8633, Chengdu calling you. 8633 frequency 123.7. Chengdu calling Sichuan 8633, Chengdu calling you. Despite many crews calling together, Flight 8633 remained completely silent. Meanwhile, Captain Liu was performing an emergency descent, following standard procedures. However, there was one detail that differed from the manual. He did not deploy the speed brakes. The reason was that the electronic flight control fly-by-wire system currently had only 3 computers operating. At minimum level, the system switched to direct lock, meaning there was no longer any protective mechanism for bank angle or angle of attack. The captain was concerned that, given the potentially compromised structure and many electronic systems shut down, deploying the speed brakes could cause another loss of control. Thus, throughout the entire descent, he decided not to deploy the speed brakes and maintained fully manual control. 132 seconds after the windshield broke, the aircraft descended to an altitude of 7,200 meters. Pressure difference inside and outside the aircraft gradually returned to balance. In conditions of low oxygen, extreme winds, and freezing temperatures, the co-pilot, who had been pulled halfway outside, managed to hold on courageously for 2 minutes, with the help of wind blowing back into the cockpit and his own determination. Finally, he managed to get back into the cockpit. Once seated, the first thing he did was secure his shoulder harness. Then he folded away the... Due to sudden cockpit depressurization, oxygen masks dropped covered with dust, forcing him to use one hand to pull the mask closer, leaving one eye uncovered. He quickly adjusted the transponder code to 7700, the emergency code displayed on air traffic control screens. Immediately, Flight 8633 appeared as an emergency situation, although other crews continued calling Flight 8633 on the radio frequency. The extreme noise from decompression made radio signals almost impossible to hear. At this moment, the crew members could only communicate by gestures. The second captain, Luong Bang, after confirming the passenger cabin was safe, entered the cockpit. Upon seeing the windshield missing, he quickly tapped the captain and co-pilot on the back to check their condition. Both raised their hands signaling okay. Luong Bang wore his oxygen mask and noticed Captain Liu was not wearing one. When signaled, Captain Liu waved his right hand, indicating he couldn't put it on. In fact, right after the windshield broke. He had tried, but failed to work because his left hand was firmly holding the controls, and his right hand wasn't long enough to reach the mask located behind his seat on the left. From the moment of the incident until landing, Captain Liu didn't use an oxygen mask at all. After the windshield shattered, the cabin altitude surged abruptly from 1.91 m to over 7.32 m. Under these conditions, both the captain and co-pilot experienced hypoxia and extreme cold. However, the duration spent in these conditions was still within safe limits for consciousness. Additionally, their body's adaptive stress response enabled them to cope better with the hypoxic environment. Captain Liu, in a state of intense concentration on flying the aircraft, didn't even feel cold or suffocated. Both pilots regularly maintained their physical fitness. Captain Liu specifically had white coat hypertension, a condition characterized by a heightened physical response to stress, which improved his tolerance to hypoxia, was higher than normal. His lack of impaired consciousness, despite not using an oxygen mask, was entirely consistent with physiology. The precise actions and alertness in controlling the aircraft further confirmed this fact. After taking the observer's seat, Captain Liu took out the electronic flight computer, AFB, and reviewed procedures for handling loss of cabin pressure over plateau regions. He showed the screen to Captain Liu, signaling the aircraft needed to navigate to Sungchao Beacon and maintain minimum required altitude above 6,000 meters. Captain Liu nodded in agreement. Luong Bang then entered the alternate landing plan into the flight control system. After finishing, he gently patted both pilots on their backs to encourage them. At 7:16, Flight 8633 finally exited the plateau region and entered the Sichuan Plains. The aircraft continued descending, turning left towards the Sungchao Beacon. 2 minutes later, Captain Luong used the microphone to transmit an emergency message. Chengdu, this is 8633. Sichuan 8633 declaring emergency, Mayday. Sichuan 8633, please repeat. Chengdu received Mayday from 8633. What's your current situation? The controllers immediately responded to the emergency call from Flight 8633. However, because wind noise in the cockpit remained severe, the crew could not hear any replies from the ground. Yet this did not prevent them from continuing landing procedures. The aircraft continued back to Chengdu after descending below 6,000 meters. Second Captain Luong Bang again contacted controllers to update their situation. Flight 8633 has lost cabin pressure, currently heading towards Sungchao. Altitude reduced to 4,200 meters. At 7:22, the aircraft passed the Sungchao Beacon and continued descending below 4,800 meters. At 10,000 meters, Captain Liu began circling the aircraft to continue descending. On the approach control frequency of Chengdu Airport, the voice of Flight 8633's crew suddenly came through. Chengdu approach. This is Sichuan 8633. We are over Sungchao, circling to descend. Although the crew couldn't hear responses from controllers due to wind noise, Luong Bang still continued blind transmissions, regularly reporting their position and intentions. This helped controllers and other aircraft in the vicinity coordinate to maintain airspace safety and showed the crew's ability to respond with extreme flexibility in emergencies. At 7:27, Flight 8633 officially entered approach procedures for Chengdu Shuangliu International Airport. The cabin pressure by then had dropped below 3,300 meters, a safe threshold that allowed passengers and crew to breathe normally without using oxygen masks. Though the danger of decompression was resolved, the crew still faced another major challenge. The projected of the aircraft was 63 tons, exceeding the maximum landing weight, meaning they were facing an overweight landing. Furthermore, the crew could not confirm if the aircraft structure, especially the right engine, had been affected by fragments from the shattered windshield, along with several systems still experiencing malfunctions, including avionics systems, thrust reverser system, and anti-skid braking system. Under such conditions, safely landing the aircraft was an extremely difficult task. Before landing, the aircraft had to decelerate and descend step by step, while also lowering the landing gear and deploying the flaps. would alter the aircraft's aerodynamic profile. This posed the risk of causing the aircraft to lose control, as had occurred after the initial incident. So what if during flap deployment or gear extension the aircraft became unstable? What if the right engine suddenly failed? Captain Liu had calculated all possible scenarios before deploying flap to position 1. He clearly discussed with Captain Luong that if the aircraft showed any unusual behavior when flaps were deployed, Luong would immediately retract them. When the aircraft slowed to green dot speed, the optimal speed for flap deployment, Captain Luong signaled with his hand. Liu responded by nodding and giving a thumbs up. Flap 1 was deployed, and no abnormalities were detected. The aircraft remained stable and controllable. As before, the two continued, coordinating via hand signals to extend landing gear and deploy flap 2. All systems remained stable. Then, Captain Liu decided not to deploy flap 3, intentionally keeping an extra 20 knots of airspeed as a safety buffer in case of right engine failure during landing. These meticulous calculations showed the flight crew, especially Captain Liu, not only followed the strict protocols outlined by the manufacturer, but also made flexible decisions based on reality, guided by experience and sound judgment. With remarkable precision, their thorough preparation, effective communication, and calm, accurate judgment helped the crew maintain safety for the passengers and the aircraft throughout the emergency. At 7:30, the plane began a left turn, aligning with runway 2R of Chengdu Shuangliu Airport, following the ILS approach system. Because Captain Luong knew that the ILS system of runway 2L was currently under maintenance. In a situation where no guidance from ATC was available, the crew once again made the correct decision. Using the remaining runway, Captain Luong immediately transmitted a blind message, informing air traffic control that Flight 8633 would land on runway 2R. After receiving the message, the controller quickly confirmed and cleared the aircraft for approach. Once aligned with the landing path, the crew initiated the landing procedure. In overweight condition, the co-pilot pressed the APU start button, but the system failed to start. Then Captain Luong coordinated with Captain Liu to deploy flaps to position 3. The aircraft remained stable with no signs of losing control. At this point, Captain Liu determined the aircraft was still in a controllable state, and runway 2R at Chengdu was long enough to decelerate, even if the thrust reversers failed. So he decided not to fully deploy the flaps, but kept them at position 3 for landing. About 4 kilometers from the runway, the crew clearly saw the runway lights ahead. Captain Liu breathed a sigh of relief. He was confident now that he could land the aircraft safely. At 7 hours 41 minutes and 5 seconds, Flight 8633 landed, without thrust reversers, without auto brakes, and at a higher than normal landing speed. The co-pilot relied on memory of brake failure procedures to prepare to disable the anti-skid system and steer the nose gear. However, Captain Liu quickly realized the brakes still worked, though only in backup control mode, which significantly reduced efficiency. With maximum manual braking effort, the plane slowed to 15 knots. But at that moment, the remaining runway distance was just over 100 meters. To avoid occupying the runway during peak hours, Captain Liu steered the aircraft into exit E8, a taxiway at the end of the runway, and came to a complete stop. After overall assessment, the crew determined there was no need for emergency evacuation, since the aircraft remained stable, as towing to the apron was not possible. All 119 passengers and crew disembodied. Of these, 27 passengers were taken to the hospital for medical checks, and all were discharged after 2 days. A female flight attendant serving at row 22 at the time of the incident was thrown up due to sudden aircraft movement, resulting in a compressed spine. After 14 days of treatment, she recovered and was discharged. The co-pilot, who was partially sucked out of the cockpit, suffered abrasions and soft tissue injuries from impact with cabin equipment. After a week of treatment, he also fully recovered and was discharged. On May 17th, both captains were taken to Chengdu Aviation Medical Center for full evaluation. Results showed no abnormalities whatsoever. On November 16th of the same year, they returned to duty separately. The co-pilot also returned to the cockpit on November 28th. After 2 years of investigation and 10 pieces of evidence, On May 8, 2002, the Civil Aviation Administration of China officially released the investigation report on the serious incident of Sichuan Airlines Flight 8633. According to maintenance data from Airbus, prior to the incident, in the past, there had been of dual-layer windshield cracking or shattering. Technical reports indicated the main cause of windshield failure was localized overheating due to arc discharge, which damaged the dual-layer glass structure. During the investigation, the special team examined 7 windshields from A320 aircraft manufactured by SGS Company. Results showed all had varying degrees of damage in the silicone layer used to secure the glass. However, Sichuan's maintenance procedures and inspection standards, airlines for the aircraft involved was confirmed to fully comply with the technical requirements issued by Airbus. However, prior to the accident, technical documentation did not require regular inspection for moisture intrusion in the silicone sealant layer. From this result, the investigation team issued a safety recommendation to improve inspection procedures for the sealant layer to prevent similar incidents in the future. After the incident, Airbus updated global operating guidelines, requiring crews to fasten seat belts immediately if windshield cracks are detected to prevent total windshield failure and pilots being sucked out, leading to potential loss of aircraft control. Fortunately, thanks to the special aerodynamic design, the front of the cockpit after windshield loss formed a high-pressure zone, temporarily substituting for the windshield's function and reducing the risk of the crew losing consciousness due to hypoxia. Furthermore, the aircraft's air conditioning system continued operating normally, helping maintain cabin temperature in both passenger and cockpit at a much better level than typical conditions at an altitude of 9,800 meters. This helped the 3 pilots avoid immediate exposure to extreme cold and hypoxia, thereby maintaining their ability to work in harsh conditions and accomplish this historic feat. On June 8, 2018, the Civil Aviation Administration of China, in cooperation with Sichuan Province, decided to award the title Heroic Flight Crew of Civil Aviation of China to the flight crew of Sichuan Airlines Flight 8633 and awarded the title Hero Captain of Civil Aviation of China to Captain Liu. These honors were well-deserved for the entire flight crew and for Captain Liu himself, who remained calm and rational and coordinated seamlessly with his team to make the most accurate decisions. Despite the freezing where verbal communication was impossible, the crew of Flight 8633 not only handled a life-threatening situation decisively and professionally, but also demonstrated the pinnacle of cockpit resource management, CRM, at its finest, worthy of becoming a classic example in aviation training textbooks.